Okay, Wildcats. Today we're looking at Journal, page 11, graphing absolute value functions. Absolute value information. Distance from 0 makes values positive. F of x equals absolute value of x is a parent function. Domain is from negative infinity to positive infinity, and range is from bracket 0 to infinity. Absolute value transformations. F of x equals absolute value of x is a parent function. F of x equals negative a, the absolute value of negative bx minus h plus k, where the negative in front of the a reflects over the x-axis. When a is greater than 1, it's a vertical stretch. When a is greater than 0 but less than 1, it's a vertical compression. When the negative is in front of the b inside of the absolute value, it reflects over the y-axis. When b is greater than 0 but less than 1, it's a horizontal stretch. When b is greater than 1, it's a horizontal compression. When it's plus h, it translates left. When it's minus h, it translates right. When it's plus k, it translates up. And when it's minus k, it translates down. If you would, update your notes. Okay, now your notes are updated. Let's take a look at the examples. All right, graph the absolute value and state the transformation equation and the domain and range. Okay, so example 1, w of x equals absolute value of x, which is the parent function. Okay, so when x is negative 3, the absolute value of negative 3 is positive 3. And this is x and w of x. When negative 2, absolute value of negative 2 is 2. When x is negative 1, the absolute value of negative 1 is 1. When x is 0, the absolute value of 0 is 0. When x is 1, the absolute value of 1 is 1. When x is 2, the absolute value of 2 is 2. When x is 3, the absolute value of 3 is 3. So let's go ahead and graph the parent function. So 0, 0, negative 1, 2, 3, 1, 2, 3, negative 2, 2, negative 1, 1, 1, 1, 2, 2, 3, 3. Okay, now we know from our notes that the domain is negative infinity to positive infinity, and the range is bracket 0 to infinity. Now, example 1 is very important because this gives us the directions for all the transformations of absolute values, okay? In order to make the shape of the absolute value, the negative 3, 3, negative 2, 2, negative 1, 1, 1, 1, 2, 2, 3, 3 are the directions that you can now use to move this absolute value function, okay? What I mean by this is, let's take a look at example 2. The plus 3 means we move the vertex that was 0, 0 up 3 units. So we're at 0, 0, now we go 1, 2, 3. There's a new vertex, okay? But in order to make the shape, we know we're going to go left 3, up 3, left 2, up 2. So our directions are negative 3, 3, negative 2, 2, negative 1, 1. HK is our new vertex. 1, 1, 2, 2, 3, 3. Okay, so from here we're going to go left 1, 2, 3, up 1, 2, 3, left 2, up 2, left 1, up 1, right 1 from, again from the vertex, right 1 from the vertex, up 1, right 2 from the vertex, up 2, and right 3 from the vertex, up 3. You can see that we have the absolute value shape. So we have now graphed the transformation of the absolute value function. Okay. Domain is still negative infinity to positive infinity, but the range is changed because it's not from 0 to infinity now, it's from 3 to infinity. So bracket 3 to infinity. Okay, go and finish up example 1 and 2. All right, let's take a look at example 3. All right. Now, the -3, from our notes, moves the vertex right 3 units. So we were at 0, 0. Now we go 1. Oh, I'm sorry. 1, 2, 3, right 3 units. Okay. Now our directions again are still -3, 3, -2, 2, -1, 1, HK, 1, 1, 2, 2, and 3, 3. So from here we go left 1, 2, 3, up 1, 2, 3. Left 1, 2, up 2, left 1, up 1 from the vertex. So right 1, up 1 from the vertex, right 2, up 2 from the vertex, right 3, up 3 from the vertex. Now before I forget, let's take a pause from example 3 and come back up to example 2. The transformation here was up 3 units. Okay. Now leading into that, let's look at this transformation. Well, the vertex was here. Appears the graph has gone right 3 units. This is a transformation. Now the domain again is still negative infinity to positive infinity. The range, because it didn't go up or down, is still bracket 0 to infinity. All right, let's take a look at example 4. All right. Now here, we were at 0, 0, but that tells us that we need to go down 3 units. So we go down 1, 2, 3. But the +3 means we need to go left 1, 2, 3 units. So the vertex has moved down 3, left 3. Okay. Now our directions are -3, 3, -2, 2, -1, 1, HK, 1, 1, 2, 2, 3, 3. But the negative in front means that we need to multiply the y direction by -1. So we need to multiply each of these by -1. So that becomes a -3, -2, -1, -1, -2, -3. So from the vertex, we go left 3, down 3. 1, 2, 3, 1, 2, 3. Left 2, down 2. Left 1, down 1. Right 1, down 1. Right 2, down 2. Right 3, down 3. Okay, the domain is still from negative infinity to positive infinity. But here the range, because one of the transformations reflected over the x-axis, it's actually coming from negative infinity to -3. All right, which gets to our transformations. We just talked about it. It reflected the x-axis. And then it went left 3 units and down 3 units. Okay. All right, go and finish up example 4. All right, let's take a look at example 5. Now, I made a change to example 5. Let's go and change the 1/4 to 1/2. Okay. Now, it looks like we need to move the vertex at -3 means we go right 3 units. So we go 1, 2, 3. There's a new vertex. Now, because I know I need to multiply the values by 1/2, I'm not going to use the same directions. I'm going to pick some, how do you say, values that I know will work, that are divisible by 2. So I'm going to use -6, 6, -4, 4, -2, 2, new vertex HK, 2, 2, 4, 4, 6, 6. Okay, and I picked these values because I knew that they were divisible by 2. So now I'm going to divide each of these by 2. So that's 3, 2, 1, 1, 2, 3. So we go left 1, 2, 3, 4, 5, 6, up 1, 2, 3. Left 1, 2, 3, 4, up 1, 2. Left 1, 2, up 1. Right 2, up 1. Right 1, 2, 3, 4, up 2. Right 5, 6, up 1, 2, 3. Okay, so domain is still -infinity to +infinity, and range is still bracket 0 to infinity because there was no vertical transformation. Okay, the transformations, it went right 3 units. There was a vertical compression of 1/2, and that was it. Okay, so if you would, finish up example 5 and start working on your assignment, and have a wonderful Wildcat day.